The next section we have here is 3.1, which is adding and subtracting fractions. In 3.1, we're going to be adding and subtracting fractions that have the same denominator. Now remember, the denominator is the number on the bottom, right? So the denominator is this number down here. And so I want you to notice that the problems here out of 3.1, the numbers on the bottom, the denominators, are all going to be the same. Okay, so the directions tell us to add or subtract and then simplify. Adding or subtracting fractions with the same denominator is pretty simple. All we need to do is add the numbers on top. 5 plus 2 is 7. The number on the bottom stays the same. It stays as 11. Since I can't reduce 7 over 11, that's my final answer. I'm going to go ahead and do the same thing for the next problem. So 2 plus 4 gives me 6. My bottom number stays as 9. Now I can reduce 6 and 9. I can divide them both by 3. So 3 goes into 6 2 times. 3 goes into 9 3 times. And there's my answer. For the next problem, 6 over 20 plus 1 over 20. Again, I'm going to do the same thing here. 6 plus 1 is 7. My denominator stays as a 20, and I cannot reduce that fraction, so I won't. The next part that I have here is 5 over 24 plus 7 over 24. So 5 plus 7 leaves me with 12 all over 24. Now I can reduce this fraction. I can divide them both by 12. So 12 goes into 12 one time. 12 goes into 24 two times. My next problem here, 10 over 11 plus 3 over 11. 10 plus 3 is 13, all over 11. I cannot reduce that fraction, and so I'll leave it alone. If you notice my next problem, I'm subtracting. I'm going to do it exactly the same way. I'm going to subtract my numbers on top. 10 minus 4 gives me 6. My bottom number is still 11. Since I cannot reduce that fraction, I will leave it alone. Alright, so for my next problem I have 18 over 5 minus 3 over 5. So again, I'm going to do the same thing here. I'm going to go ahead and subtract. So 18 minus 3 is 15 over 5. I'm going to go ahead and just divide it out. 5 goes into 15 evenly 3 times. For my next problem here, I'm still doing the same thing. 25 over 12 minus 15 over 12. So 25 minus 15 leaves me with 10 all over 12. Now again, I can reduce this fraction. I can divide both 10 and 12 by 2. 2 goes into 10 5 times, and 2 goes into 12 6 times. For my next problem that I have here, I have 7 over 4 minus 3 over 4. So 7 minus 3 is 4. All over 4, and 4 goes into itself 1 time. Alright, so for my next problem here, I forgot to put the directions, so I'm going to tell you what it is I want to do. Here, I'm looking for the perimeter. If you recall, the perimeter just means the distance all the way around. So I'm going to take all these numbers and I'm going to add them up. I'm going to take 4 over 20 plus 7 over 20 plus 9 over 20. Okay, well, I'll give you a hint. My bottom number is going to stay 20. If I add 4 to 7, that's 11. 11 plus 9 is 20. 20 divided by 20 is 1. Since my units here are inches, my answer is 1 inch. Alright, so my next problem here, I have a pie chart, and I'm going to go ahead and answer the questions using the pie chart. So the first question here says, what fraction of a full-time U.S. college student's weekday is spent on eating and drinking, grooming, and sleeping? Okay, so eating and drinking is right here. So I have 4 over 100, okay? And I also need grooming. Well, grooming is 3 over 100, so I'm going to add that. And sleeping. Where's sleeping? Sleeping is down here, 36 over 100. Okay, so again, I'm going to add all those numbers up together. So I know my bottom number is going to be 100. So 4 plus 3 is 7. 7 plus 36 should give me 43. I can't reduce 43 over 100, so that'll be my final answer. Now, I got a couple more problems here. The next one says, what fraction of a full-time U.S. college student's weekday is spent on working and related activities and educational activities? Okay, so I'm going to look for a couple of things. I'm going to look for working and related and educational activities. So I'm going to scroll back so I can look at my graph. Okay, so working and related activities is right here. So there's 11 over 100. So let me scroll back down. Let me write down that number. So I have 11 over 100. And I know I'm adding, and I'm going to look for educational activities. Educational activities is right here. So let me bring that down a little bit. And now I have 14 over 100. When I add those two numbers together, that's going to give me 25 over 100, which I can reduce to 1/4. All right, so I'm going to come back up here. I'm going to scroll back up to the top, and I'm just going to sort of clean up this here so that I can continue with my next problem. All right, let me get my pen back. Here we go. And let me scroll down to the next problem. So the next question here says, how much greater is the fractional part of a college student's weekday that is spent on leisure and sports than on traveling? When it's asking me how much greater is one number than another, it's telling me I'm going to subtract. So I'm going to look for my first number here, leisure and sports. So I'm going to scroll back up to the top. Leisure and sports is right here. That's 16 over 100. So I'm going to write down that number. So I have 16 over 100, and I'm going to subtract the number I spent on traveling. Well, traveling is over here, which is 6 over 100. So I'm going to bring this back down. I'm going to put 6 over 100. When I subtract those numbers, that's going to leave me with 10 over 100, which I can reduce to 1 over 10. All right. And so for the last problem here out of 3.1, it says, how much greater, again, telling me I'm going to subtract, is the fractional part of a college student's weekday that is spent on sleeping than on educational? Okay, so I want to come back and I want to look for sleeping. So sleeping, we spend 36 over 100. So I'm going to write that number down. So I have 36 over 100 minus the educational part. So the educational part is right here, which is 14 over 100. Let me scroll back down. So 14 over 100. When I subtract those numbers, 36 minus 14 should leave me with 22 over 100. I can divide them both by 2. That's going to leave me with 11 over 50 if I divide them both by 2.